Okay, so let's have this problem. Find the equation of the hyperbola with vertices at 5, -3, -1, -3, and focus at 7, -3. So first we need to graph the given. So using the given coordinates, so we have the vertices, that's 5, -3, then the -1, -3, then we also have the focus, the 7, -3. Now, take note that focus always inside the parabola, so therefore our graph, this one, so opens to the right or opens to the left. Now, looking for the graph compared to this table, so our parabola or hyperbola is in horizontal position. So therefore, we're going to use this formula, the x over the a squared formula. So this is the formula that we're going to use to solve this problem. But these are the things to remember for the hyperbola. So a, that's from center to vertex, or b, that's from center to minor axis, and c, that's from center to the focus. Okay. Now, since we have given the coordinates of the vertices, so we can find now the center of a hyperbola by solving the midpoint of the vertices. So using the midpoint formula. So we have x sub 1 plus x sub 2, y sub 1 plus y sub 2. So these are the values. So you just have to substitute these values on this formula. So x sub 1, that's 5 plus -1. Then we have y sub 1, -3 plus -3. Then use simplify. So 5 plus -1, that's 4. Then -3 plus -3, that's -6. Reduce. So 4 over 2 and -6 over 2, that's 2 and -3. So this is the center of our hyperbola. That one. Now next, since we have the given focus, and focus to center or center to focus is c, so just compute the distance from center to focus using the distance formula or the counting method. So I'm going to use the counting method. Now, in counting, so from this point, so start counting on the next point. So this one, 2, 3, 4. Again, start counting on the next point. So we have 1, 2, 3, 4, 5. So therefore our C is 5. Next, so we have, since we have also the given vertices, and from center to vertex is A, so compute the distance from center to vertex or vertex to center. So still using the counting method, so from this point, start counting on the next point. So we have 1, 2, and 3. So therefore A is 3. Now, since we have the values of A and C, so we can solve now our B. And B, formula for B in hyperbola, so B is equals to square root of C squared minus the A squared. You need to substitute this value. So that's 5 squared minus 3 squared, or that's 25 minus 9, and that's square root of 16. So B now is 4. Okay, so from our computed value, that's center, that's 2 and -3, then A is 3, B is 4, C is 5, and this formula, so you just have to substitute all these values to this formula to find our equation. So from the center, so 2 -3, so our H is 2 and K is -3, so substitute these values now. So we have X minus H, H is 2, Y minus K, that's K is -3. Then we have A squared, that's 3 squared, then B squared, that's 4 squared. Then you simplify. So X minus 2, this one, Y minus, so double negative, that's positive. Then 3 squared, that's 9. Then 4 squared, that's 16. And this is our equation.